Hello everyone and welcome to today's live stream. We've got a lot to go over today because a lot was added to, well, geometry nodes this week and I guess the past week because I missed the last one. But yeah, no, a lot of stuff. We got a new version of cloth simulation and we got new hair simulation. These are experimental features, which I believe in this case means that the XPBD node is merged into main and will be in 5.2 regardless, but the node asset groups are still in the preferences experimental tab, so you need to enable that before you get access to them. I'm not entirely sure, which I should probably check up on that, but that's all good. And also, let's see, the get attribute names node got merged, which I'm so happy about. This went through so many iterations. I think around 14 months of, well, different iterations on and off. The main thing I was waiting for was lists, which now we have. We can now filter by data type domain and all that, which means that geometry nodes can now see what the spreadsheet sees and use it. Or I guess the store named attribute node, it can see all the attributes. But now we can actually get them and use them. So now we can do stuff like procedural or automatic, like armature deformation, normalizing vertex groups, which I've already used it for, getting the UV maps, iterating over attributes, and all that good stuff. It is quite a good node if I do say so myself. That's why I went through and tried getting it in. But also, let's see, what was it? There's the transfer attributes node, which is also new thanks to the cloth dynamics and stuff. And this node is used for like when there is tearing. So with, oh, I reset the simulation. Whoopsie. With this, let me check that the stream is doing good. Okay. With this cloth setup, we can see that it has some tearing going on. With this, it is splitting up the mesh, as you would assume, but also transferring all the attributes properly between the two versions of the mesh. Which, actually, when I think about it, I need to actually look how this happens under the hood. But I don't think this was intentional, but we can link these two together, meaning that every attribute, regardless of, all this, can be transferred over. And I don't think this was synced up. I was working on this independently, and I didn't even know this was being cooked up. And I believe vice versa as well. But they should work completely in parallel, which is fascinating. I haven't had too much time to look through all of these setups because they are extremely complicated. The cloth dynamics, as we can see here, it seems pretty complicated, but there are 50 node groups in here. 50, or around that. And then the XPBD simulation stuff, there is a lot going on in here. The levels can go down a few. Where's the part? Yes, the effector stuff here. I think the max levels we can go down is like 4. I don't think it goes down more than 5. No, it can. You can go down 5 levels in this, which is extremely intimidating and very hard to track, especially given the closures. But from what I've gathered, I'm amazed that this runs in real time, because I would imagine the overhead is considerable with all of these node groups. And I'm not used to how complex this is. I needed to make some hair simulation stuff in the past, and it was fairly complicated. But this is another level. This is another level. So with the intro out of the way, I think everyone is here now. So yes, with this setup, let's go and start from scratch, or somewhat from scratch, because it's very easy to add in this kind of stuff. So let's just go and subdivide a cube quite a few times, and let's go and add in just a cloth dynamics thing, which if you have the experimental setting enabled, you should see cloth dynamics. It will be under the simulation tab rather than the physics tab. You'll be able to tell because it does not have an icon. And we can see that once we add this, it just falls, which means that we need to enable the effectors, which in this case is this collection, but also brings up another thing. Collisions are a little bit funky with this setup. I don't know why I had the subdivision after that. But there are node groups for adding in colliders. Basically, it seems like, and again, I haven't had too much time to look into this, it seems like most of the, the physics stuff here will be replicated in geometry nodes. That seems to be kind of the goal in this scenario, which I quite enjoy. Making everything just so procedural and editable and all that. We no longer need to rely, or heavily need to rely on updates to fix stuff, and we can add in our own features to the cloth sim stuff. I've seen a couple of people add in pressure and stuff like that, and it is fascinating. But with the collider node group, I just added that into here, which let's go and just reset that. You can see nothing here, and then we add in collider. Click that right there. This doesn't need to be deforming. Do not turn on edge contacts, because it's either extremely laggy, which as someone who worked on edge-to-edge collision before, or no, not edge-to-edge collision, because I worked on two, like, either it was camera frustrum culling, but with bounding boxes and all that. Edge contacts are extremely expensive. I have no idea how people got that to work in real time. But I turned this on in one of my simulation tests, and it slowed it down to either 1 frame per like minute or just crashed Blender. I'm not sure. But just leave that off for the time being. I think that's still a work in progress. This is still very experimental. But with that, we can see this works quite well. I'm going to turn off the subdivision here because I want this to be real time. I don't have a good CPU, or it was good for the time, I think. Well, I haven't upgraded it in like 5 years? No. 3 years. 3 years. It's like an Intel i7 or something, but it's supposed to be a good version of one of those. I need to get a better CPU. But we have that. We have just the general solver. We have the substeps, constraint steps, the structure, the friction, the collision radius, which if we go and bump that up, we should see, yep, it just sets a little bit higher than normal, which is always good to see. There is no self-collision. They may add that with like some SDF stuff, which is another funny thing. With all these collision stuff, and with, I guess, most things in computer graphics and stuff like that, it's always like, okay, we're going back to voxels. Voxels just make everything easier. Sign distance fields and all that. Which, hey, I'm okay with. Voxels can be rather expensive to compute on the CPU, but I'm sure they'll figure out a good way of making it work. I'm also quite interested in, what was it, the rasterized to volume node that I believe someone was working on for like the hair interaction, because that's what they use in movies and stuff like that. For hair collision, you don't just try to compare all the edges to all the edges. That's how you implode. Not the simulation itself, but your mental health. You go and voxelize it so that you compare stuff against the voxelized version, and you just simplify the collisions greatly. Rasterized points, yes. Which I would say is really good. If they can get that with points, edges, and all that, that would be fantastic. And also, that could also potentially, allow for rigid body dynamics as well. Though I'm just gonna wait for Jolt on that side because, yeah, I made a version with help of rigid body dynamics with only one rigid body, and it almost worked, but not quite. So I'm just gonna wait for the official version. Okay, and with that out of the way, we have gravity, of course. If you want to add in other effectors, which I believe, let's see, where are the other effectors? So, effector, force? Is there a force? Let's go and look at simulation. We have attachment surface, collider, cloth dynamics. These two I need to look into as well. Are there force fields in here yet, or was that not added? This might be in one of the test files and not this file. But you should be able to add in infinite amounts of custom effectors to this. I don't know how those work, so I won't add them in just yet. For tearing, it's as simple as checking a box, and the mode is just set to all, group, or Voronoi, which Voronoi is always cool to see. So if we turn this down below 1, we should see that, yep, it tears and it falls. But this will work with like certain stressors, so if I set it back to all and set this to be 1.1 should be good. Let's go and delete the plane right here and then copy this collider. We do that and then bring these here. We can see that we can go and shatter whatever we want. And I want to try so many things with this because this is cool. I actually don't know why this is not real time right now. It should be. I've tested with heavier meshes than this and it was fine. Maybe it's being read somewhere else. Actually, from my tests, performance was better with this cloth simulation than the previous one. Just force, I think. Yeah, let's go and check force. Nah, it might be in one of the test files. But yeah, we have that. I want to try, like... I don't know, this seems like if I had, like, a space station and then I ripped it apart and all that and it exploded, that could work really good. Turning gravity off is also very, very nice. I don't know why it's lagging so much. It should not lag. In my tests, this should not lag whatsoever. Or maybe it's that? I don't know. Let's do a little... The 16 milliseconds. Yeah, no, that shouldn't lag. It's close to lagging because of that, but something else is... Oh, wait a minute. Duh. I keep forgetting I need to turn off that and that. There we go. It's lagging because the other thing was still visible. But yeah, we can just go and move this around and just go and completely obliterate it, which is so much fun. Then, you know, turn on gravity and just make it go whee. But yeah, that is grand. With the previous setup that you saw, let me go and turn off this one and enable one of these. Delete that one. With this one, I'm using a group to go and tear the mesh, not by the length, but just by a certain value. I had particles spawning from the tear system, the tear edges and stuff like that. Just a simple setup. But with this, for the actual tear setup, I am using shortest edge paths, and then using a setup so that I can go and direct where the things are going, and then get the proper gradient value from that. That's why there's two of them, and just with all that. So with this side, this actually makes the edge path selection, or just the edge path, and then that goes through. And then with this one, I go and stack up the edge costs so that I can go and move the gradient and cause these tears. So that is good. And then I triangulate the mesh and all that, which is probably making this a lot slower. So let me go and turn that off. Also turn down the subdivisions just to make it, you know, real time. And for some reason... Oh, is that because of the 0.999 thing? Yeah, probably. But yep, we can see that that works quite well. The cracks just propagate, and it all splits, and it's all fantastic. And good. And also I have the tearing below one, so it just automatically tears. We don't need to wait for it. And yeah, it's a little bit complex, I know. I just tried to optimize it. But we just move the total cost over time, get the less than if it's less than that, and then also, if it is part of the original tear path, then it will tear. And that is good. That is good. I think this will be one of the main attractions for 5.2. Yes, it is still experimental. Just got here late. Will this be in 5.2? It should be, though it's still experimental. Especially, I think... I've run into a few little issues with this. Either this or the hair dynamics, because the hair dynamics I don't understand. I've tried using them on a few little tests, and from the demos that I saw from the devs, it seemed to work very well. But in my setups with hair, it seemed to be very laggy and very stretchy, which I didn't see in their situation, so I must be using it wrong. But actually, speaking of that, let's go and transfer over to there. We have 40 people here. Oh god. I hope you all enjoy. Let's go to simulation. Is this the current one, or no? That's the wrong one. Open recent. 5.2. Where did I put that? Ah, here it is. Here it is. So another big thing that I hope... Oh, this was another test of the cloth tearing with the shortest edge paths thing. I think this was the first try I had at it, and god, that's some good stuff there. But let's go and check out the head that we have here, which has the simulations. I've decimated it so that hopefully it runs semi-real time. But this is what I'm talking about. It is extremely stretchy, and there aren't even that many points here. Maybe this is way too high for what I was expecting, but even this is a decimated version of the effect. I need to do more testing because the devs had things like this, and it was not this stretchy. And it, from what I think I saw, it ran in real time. This is with 10 substeps and 5 constraint steps. Maybe I just need to bias these so that it's like, oh, I could go to 0. Yeah, let's just set it to 0 and see what happens. Oh, I should not have been able to set that to 0. But if we do, oh. Yeah, no, this is what I'm talking about because, yeah. It's, I don't have the balance right, or like it's a certain type of curve that is like subdividing a bit more, but it shouldn't be. I just need to go through and do some more tests because I don't fully understand this. Let's see, 2 points. Let's do curve to points just to double check. Evaluated. There's a good amount of points in there. It's not that dense. There's a lot of hairs, but the individual hairs themselves are not that consequential. Let's also go and set points radius, just so that I can actually see what's going on. Yeah, no, there's not that much going on. Oh, also the the mat caps look very interesting on points. That's funny. Let me go and switch this to the studio so that's a bit easier to see. But yeah, no, that's not too many points. They're just stretching a lot. Or there's not nearly enough stiffness. So there's stretchiness and bendiness, and both of those are set to pretty much 1 or 0. I think if I were to set the bendiness to be full, that makes it even worse. No, it makes it the same. We said the stretchiness, that's what makes it worse. Root bendiness. So I think this is trying to retain its original shape. It's just having a really hard time doing so. Again, I haven't had much time to test this. So let's see. Mass too big? No? Oh, yeah, that might be a thing. No, I think I lowered it. Let's set this to be very, very low. Seems to help a bit. Let's turn off gravity and see what happens. Okay, so gravity. But even with that, it's very jelly. It's very jelly. But yeah, I just need to look through it and see, because the examples from the devs were much more stable than this. So it's possible I just must have a setting or something wrong. This is with 5, but let's reset this to 0. Try this again. But yeah, with that we can see, yeah, it's it is something. And it's still trying to reset, but really taking its time. That. Interesting. Let's see, there's maybe it's these. Let's go and set both of these to 0. Oh, no, that's a terrible idea. Well, let's go and give it a try. Oh, that is lovely. Linear damping. See, that's good. Then angular damping. Yeah, no, that doesn't affect it. With surface collision, you need to... Oh, yeah, setting this up was also a bit of a pain, which I didn't fully understand, because I was just playing around with it. I do want to try like 0 gravity or underwater hair, because that would look amazing. Because there's a lot of possibilities with this I need to try out. I just, again, haven't had the time. I had one or two particular issues this week with a work project that nearly burnt me out, which is so fun. It's so fun when a technical issue just completely kicks your rear and makes you not want to do a lot of procedural stuff. But I survived. But yeah, we have the friction. And that friction... Maybe it's the friction. What does the friction do? see. We're just gonna be playing around with this and testing. Is the friction like collision friction? No, because that's in there. Surface collision, deforming, surface friction. Yeah, that's right there. Do not turn on edge contacts. Don't do that. Yeah, if you want your computer to survive, because I can turn on surface collision. It does become a lot more yeah, it becomes a lot more laggy. And then if I turn on edge contacts, we can see that in terms of performance, we have no performance. Absolutely none. If you can hear me right now, that you are lucky. Because, yeah, no, let me just go to the be right back screen. Because, yeah, no. It is... We got point... It did update the frame once. I am closing Blender. Yeah, no, don't turn that on, because that must be a bug. That has to be a bug. Either that, or let's go back here, turn on that and that again, turn that off. Or maybe this mesh is just too dense? I mean, the mesh is kind of dense, but not that dense. If you were, like, doing this in production, you would just have a proxy. So that, you know, it would be fast enough for you to actually interact with. But is this really too much? Is it because the mesh is not... No, the mesh is technically enclosed. Not well, though. I believe I just filled that in. But yeah, something... Maybe it's that the eyes are disconnected and all that. Though this mesh is enclosed. Oh. Oh, I unsubdivided this mesh, too. Ages ago, because this was from an old hair simulation project. Or attempt. But yeah, that's, yeah, it's a bit rough. In terms of, performance. But, yeah, I'll get back to that, because I also want to show off the, what was it? The deformation, using the node that I guess pioneered. It still has some issues, as we can see here, with my Armature deform test. The devs helped a lot with some of the technical issues with this node and design changes and stuff like that. Jax added in these very nice panels and fixed some of the issues when there were, like, no attributes to get. But here, with this setup, it's an attempt at normalizing weights and then armature deformation. Which I don't know why the armature deformation isn't working. I thought it was that the weights weren't normalized, but when I normalize the weights, it makes it even more inaccurate. So there must be either a stray thing in here that doesn't work or something else. Which maybe I just need to fix a few things. Like right now, there is no test if the bone actually exists in the rig, so it's just adding in some stuff, even though... If the bone doesn't exist, it should be fine. There should be... I should have an option for checking if the bone actually exists, which maybe I can make a patch to add that in if it's actually there. Because right now, it says bone not found, which means that the boolean for that is already there. I just need to make a patch so that the exists boolean has an output. And then if that output exists, then the error will not show, or if it's actually connected, the error will not show, so that you don't get bombarded by that, so that it can go and skip any iterations that are invalid. But yes, we get the attribute names, put that into the iterations. I should put a maximum in here so that you can't send it into infinity. So the iterations fire, and then with the bone info, we get that. I guess if I wanted to make this even better... Actually, no, this is pretty good because it'll skip any non-deforming bones with this, or it'll go over any bones that don't have a vertex group. So it is efficient, more efficient than even a get bone names node would be. So that's good. Which actually, yeah, a get bone names node would also be good for this. Looks like I'm gonna make a new node. I really... Oh, I forgot to mention, the scene time node got approval from 2 of the devs. So the shader scene time node may make it into Blender 5.2. The only issue is that it's currently failing like 4 of the 5 or 6 tests because it's missing an .oso file, which deals with OSL. I don't know what that does, so I need to look into that and fix it. So there's a lot to do, or I'm assuming that it's just missing one file for certain platforms. So I need to look into that and fix it, which probably, well, that node has gone through a lot of iterations and 40 changed files for a scene time node because Cycles did not support that kind of data before. That's why we didn't get the scene time node. Cycles straight up didn't support that kind of scene data. And then refactors and all that, it's a whole story. But we're close. We're close to actually getting that in. Another major annoyance being solved. The age of hashtag frame maybe will be eliminated for good. Because apparently that's a lot slower than just having a native node for it. But if I were to work on that node again from scratch, I would just make a node group asset because apparently let me turn off normalized weights again. Because apparently they fixed the issue with some of the attributes not updating correctly when you changed frame in Cycles. So just a node group asset would probably suffice, but the native implementation with the proper scene data is best. So I've already changed files, but it'll be worth it in the end. I hope. But yes. What was I doing here again? Oh yeah, just showing this off. But yeah, it just gets that data, gets the bone info, compares the rest pose to the current pose, offsets the bone rotation and all that. There's something with like double quaternions for preserved volume that I think someone tried at one point with their implementation, but that didn't have the automatic attribute name stuff, so this can help with that. Gets the weights, does all that, stacks them up, and then you offset according to the weight. I should rename this from weight. Yeah, but it's not the most complex setup, it just needs a little bit of wrangling right here. So that should be good. Let's see. Try making cloth force with random forces on each point with some fluctuations. So this would look like a jellyfish. I have tried that when I tried implementing pressure. Some people have implemented pressure and it looks amazing when something explodes. I believe Celestial Maze made like a battery exploding and it looks so good. Just a little bit of physics goes a long way, and we can edit the physics system. It's amazing. It is extremely complex, don't get me wrong. Like that XPBD setup, I will be like spending an hour looking into. But we can modify it. We can do so much with it. Even maybe potentially implement our own self-collisions, which we'll need to see. But I do hope that we get that rasterized to volume node. I hope we can make it work with points, edges, faces, and all that. Or, no, we already have the SDF, the mesh to SDF set up. Which that could make things good. I would probably need to upgrade my PC for it to run anywhere close to real time. Because again, running on the CPU, simulations like this are slow. And next week, geometry node, muscle systems. Yeah, no, muscle systems are possible, I think, potentially. Though those rely heavily on collisions, which we are not very, very good at. Yes, but this node is good. I need to add in the exists output to this, which would be very simple because it's already outputting the error message, which means a boolean is already there. I just need to expose it and send it out. Yeah, I could do that this afternoon. Not bad. Oh, another thing, UDIMs. So there was there's the image texture node. This was another thing that almost burnt me out. I needed to use UDIMs with this node, and currently this fails when UDIMs are used. Looking through the code, it is much more complex than I thought it was, and it should be possible because the function that it relies on is rather generalized. It's used, everywhere. So that part does support UDIMs. It's just putting in the multiple image buffers or the caches. I forget what. It's been a hot minute. Then making the multifunction use the image buffers and all that. And then also having the enum input, which kind of like changes the original. Does it change the original image or does it change the interpretation? I don't know. And then like with the texture sockets, it's all... And then it made me think about like, oh, the general design of the image texture. Like, should the image input have the linear repeat and all that? Should all that be in here or with the sampler? And no. The linear repeat and then whether it's a movie, image, or all that should be in the sampler, not the getter. Not the data block thing right here. And then, like, because I'm thinking, because Jax was toying around with the idea of porting this node into the shader editor so that we get the image socket, which we desperately need. People have been wanting that for ages. But it implies that this node will need a rewrite, not a rewrite, kind of a redesign, I believe Jax said. So that it will be as functional as the shader image one, because this one doesn't support UDIMs. I think with the frame, I do really like how there's a frame input while the other one doesn't have it. Maybe menu inputs would be good for use with node groups. But yeah, I think a more general redo of this would be needed before UDIMs are added. Because it's just beyond me at the moment. Though, if anyone knows how to do it, please let me know. Let me know, because that was a pain to look around. But yes, so we have that. Let's go back to the simulation side. And let's try to do some fun little experiments. Oh, my mouse is... Is my mouse dying? Oh. There we go, okay. My wireless mouse does not like it when I donk it against my keyboard, which is a Logitech mouse. It should be fine. It's my first wireless mouse because I always liked wired mice, for this reason specifically. Yes. Oh, I have another demo to show you all, even though this one... Here, let me go and render this because it would look a little bit graphic if not shown. So with this one, it's like, I don't know, some kind of rock guy, and then the, like, rock surface erodes away, showing, like, the molten interior and the skeleton. Looks really, really cool, even though it is lagging, severely. Oh, wait, why did I do that? Let's just let this cook, and then we can see it play in nearly real time and all that. Yeah, just the tearing, it works so well. I won't be posting this one because it is a bit too graphic for my usual stuff. I know some people would be like, oh, that means I could go and make some really interesting effects. Some, you know, not make it abstract like this. But it is cool, nonetheless, that we can do this. Like, there's like a radioactive guy somewhere where, like, this happens. Somewhere, I remember seeing something about that. That's a cool little thing. Well, let's go into a new file to go and experiment with this. Let's see, do I have the... I have a... Yeah, let's go back to the test file so that I can go and edit everything and it all still be good. So we have this basic setup right here. We'll have this in here. This will be D1 for demo 1. Nope, move. New collection. I keep forgetting that shortcut changed. Again, with this one, it just does the slice, the particles fall. Let me go and also put the particle sim in there. That happens, and that is all fun and good. That there, that all falls. Let me go and turn off the subdivisions on the collider just so that we get that in somewhat real time. Because it's almost real time. It works quite well. Actually need to look into the collision system for this because I actually don't know if that's done internally or externally. Let's take a look. So there's the XPBD simulation. I really need to investigate how this works because here are the effectors. Object effector, and then there's all that, get list item, the collection children node, which is another one that I worked on. Though the devs helped a ton with that as well. And then there's, yeah, just getting that. There are so many node groups, which makes this a geometry bundle. Then that goes into there. Okay. So there's just that. So that could be ungrouped and be fine right there. It just gets that. Like, it's just the management side that really confuses me. Because there is a lot that happens here just for the management. And then there's typed bundles, which is a whole nother level of complexity that I don't entirely get. Like, you get a typed bundle, you put everything into the typed bundle, and then you put that into another bundle. So it is a bundle. Then you put it in another bundle. Then you put it into there to make a giant bundle, which is like this. So, let's see. How many bundles are there here? Yeah, 1, 2, 3. Oh, I think that goes even more, or maybe that's it. Gravity bundle, positions, all that. Effector 0, all that. So there's a lot going on. And then, oh, another thing I noticed. Yeah, I think I'm starting to see a problem with the amount of node groups here. Though this could easily be solved by just putting a period in front of all these so that they're actually not visible in this setup, because this is just with one cloth sim thing. Imagine having multiple, like this and hair sims going. Yeah. And we don't have a search in here, but we just have that in there. So there's a lot to digest with all that. Let's go and try a little pressure setup with the cloth tearing. So I don't know how to do pressure, so this will be a test. Let's go and get the cloth dynamics right here. Going to go and pack this one in, so we have all of that. So for the effectors, let's go and take a look at the collision effector. Because we've seen the cool stuff. We're now going to dabble with the internal. So if let's see, if you find this overwhelming, I do not blame you whatsoever. Where can I play with this myself? This is in the main 5.2 build. So just go to Blender, download experimental, get the daily build, which is what I did today. Enable, go into preferences, and then enable the experimental geometry node simulation groups, which I still forget if the XPBD simulation is experimental or if that's actually in, like, will just straight up be in 5.2. I think I'd say it's a 50-50 shot if these node groups make it into 5.2 and don't get taken out of experimental, because there's still things that freak it out, like the edge collisions, stuff like that, though they're working very hard on it. Yeah. So we'll see about that, but I hope we at least get the XPBD simulation. I tried once to go and just use the actual node itself, and then say, oh my god. That is a lot. Here, let me move my mic a little bit. That's a lot of stuff. That is a lot of stuff. Filter, local, position, normal, friction, collider, filter, that is, wow, that's a lot of data. That's nested bundle types. Oh my gosh. That is so much. You know, back in the day, you know, when it was just geometry, you wouldn't even need a bundle. You would just have a piece of geometry running through, and then just a set, like, you know, just set velocity, set position. No, it was so simple back then. Now that we actually get serious, it's all this. And then that's just for this node. Never mind the multiple layers of, you know, getting all the world items, applying the geometry cache, which is just evaluating tons of closures, which, if that exists, that does that. And then the amount of repeat zones in this must be astounding, because for each sim geometry happens like 15 times in this setup, because it happens here, here, there, previous world items. Okay, that's not too bad. That's just a management stage. Then we have all of this. But there are so many repeat zones, which I'm astounded that the overhead is still not too bad with all of this. It is a lot. Oh, and I don't understand. And the thing is, I haven't been able to make my... What I wanted to do today was figure out how this worked so I can make the simplest version of an XPBD simulation, and then build out from that so that I can understand how it works. But for my tests, I couldn't even figure out how that actually functioned. Let's see, the tearing. This is what I want to do. As for tearing, we get to see a unit of something that just works on the actual geometry that exists. We get the length and then the rest length. We go and capture that, do some stuff, get the Voronoi for potential stuff. We go and hash that for the face group boundary, which is good. Oh yeah, no, I did this setup independently when I was trying out some of the tear setups. But yeah, that's good. Voronoi rest position, yep, that's good. Then you do that and that. So you either do it with the Voronoi, do it with the edge length, or just with a group. And then you have that closure, and then you do this as a post solver, which we can see. Just another combined bundle. Which, that... I think, let's see. What is this? What is your name? I cannot edit the width. Width. Custom geometry stage. So this doesn't need to be a node group if I'm... Okay. So this is something... I don't need this node group in order to make this work. I just need the typed bundle. Again, typed bundles are things I don't understand. I'll figure it out. I'll figure it out. So the closure just gets sent into there, which a closure, for those of you who don't know, think of it like a portable node group, just a node group as a socket. Send it through, it all works just fine. So yeah, here I'm going to do a little thing where I'm either... Oh, right. I need to, let's see, show node options. We're going to duplicate that, which may corrupt the entire setup here, but it should be a vector. And here, I'm going to assume... Let's see, what data do we have here? Do we have... Oh, it's just regular velocity. Lovely. Velocity. We're going to take the velocity. We're going to get the... I forget, for pressure, is it just the... let's see. We need to get the average. The field average, because I love that we have this node. I love that we have this node now. My brain is running faster than my voice. So I'm tripping up over my words again. Did we normalize this? Yeah, let's go and normalize it. Go and scale it by a bit. So just to put a constant force going through this. So we do that, vector add, plug that into there. Because as far as I know, is there a... Oh, wait a minute. No, I can't get the attribute names because this hasn't actually run yet. This is in a closure context, which makes debugging a little bit more difficult to deal with. Turn off gravity, turn on tearing. We can see here that we're starting to get that jellyfish appearance, and then if we turn it up high enough, should see that it should explode. Though, it is not good enough. Let's go and subdivide this again. Let's go and move it over to here so that we don't need to deal with that collider. Oh, yep, there it goes. We have that. Let's go and turn up you. Oh, okay, so we can't turn it up too much. Just have it be like that. I highly doubt this is how pressure is supposed to work. We can see with that general pressure, we're causing a bit of rotation. And, yep, there that goes. So it's just like that, but how do we... Let's apply this, because we have the rest position. Let's go and get some noise. 3-dimensional noise, of course. And we're going to use a map range to set like where it will be weak or strong, and then use a multiply. Regular old multiply to go and set how powerful it'll be. Because what I want for it to be, yeah, something like that. I don't know, why is it, oh, okay, it did tear in a couple of places. Let's go and turn this down even more. Stretch. Maybe I just need to lower the threshold. Ah, there we go, yes. So I want it to, let's see, let's set it to 5. Other people who added in pressure probably know how to do it properly. But I assume that they'll, if this gets taken out of experimental. There we go. Look at that. So it's like that. It explodes. The tears still happen and cause that. So cool. So cool to see. Then for the structure. Okay, there's no plasticity for it. I was thinking about maybe making a metal simulation, but I assume that could all be added in. I assume it could already be added in if I know what actually happens with this. Let's set this to be 6, because I want this to just... Why is it not building? It's being compensated for too much, because I want it to... Oh. Goodbye. Wait, what's up with that? What is going on there? Let's see. Nope, just one side is like pseudo-imploding. It's always cool to see. Interesting shape as well. Let's go back to 0, 0. Then, oh, wait, that's not good. Oh, no, okay, it is going in a determined direction every single time. Oh, no, that's just because of the cache. Good, okay, it is going in a general direction, and there's no weird, parallelization, things going on. Let's go and use the regular position, because I want to see if that happens. Oh, wait a minute, is this flipped the wrong way around? Ah, no, it's not. Though that is quite cool. The implosion. I want that to be very low. Oh, wait. Look at that. And then it just implodes. The tearing still occurs and all that. And then... I did swap that around, yeah. So let's go and swap it the other way. Ah, look at that. So cool. I need to try so many things. I like my nodes al dente. Same. Same. Okay. Maybe I just need to put this as a set position. I know it's supposed to be a force, but we just do this here. And, yep. Bit much, so let's go and lower that. So here, yeah, that's the look I got before. I have a jellyfish, almost a reaction diffusion style thing, but would start to spin and then that happened. So that, even though it's not physically accurate in the slightest, it's really freaking cool. You get to see a general spin and then tears itself apart. Lovely. Oh wait, I could just go and do a cross product and then make it spin and then make it fly out. Like, yeah, no. That's the way to go. Just actually make it spin. Which if I knew how the effectors worked, I could make that actually function, but fortunately I do not. I just need to cross product that with that, set it to be 1. That's fine. Plug that into there. So now, oh, a bit too much right there. So just like that, and then boom. So we need to make it a little more resistant to that. Because it'll go stack up, and then, oh, that's interesting. That's one way of making a cheese wheel. How about that? And then the linear damping. Let's go and turn that down. I want it to continue. 0.1. Okay. So I just want it to keep stacking. No terminal velocity here. No, it's still reaching terminal velocity. It's not going fast enough. 7.5. Run it again. There we go. Look at that. Beautiful. It's so hard to navigate the cloth group. Yeah. Ideally, again, I'm looking at the internals. Ideally, you never look inside this node group. You just have... Actually, yeah, I don't need to go inside this node group because I can just make an effector that makes pressure happen. It's like the gravity, that could just be an effector. The tearing, I think even that could just be an effector. All of these are just effectors or just closures running at different stages. So, no, I don't need to go inside this node group whatsoever. I'm doing it for fun because I want to see how it actually works. That doesn't need to happen. Let's go and set this to be like 1.5. Really just make it tear itself apart. So again, you don't need to go inside the node group. Oh, wow, okay. Cool. It's just like that, and then at some point, it'll just become too much, and it will fry itself. Let's set this to be 1.05. I have a feeling. Yeah, we get more spectacular shreds if that happens, yeah. If I put in more constraint steps, we might get a better look. Where we can go and speed it up faster. There we go. I want it to be... No, I don't want it to be faster. Will you explode? It's going way too fast. It'll explode. There we go. Okay. That was the limit. I think the lower speeds are a bit better. What GPU do you use, and do the experimental GeoNode cloth and hair simulations run on the GPU? No. Geometry nodes runs entirely on the CPU. The GPU is not used whatsoever in these processes. Because, like, even Houdini, for the most part, is CPU only. I forget which parts of Houdini are actually GPU accelerated. I think it's only... It is... Cops is GPU accelerated, right? I forget which parts. But most simulations are done on the CPU, because you don't need to deal with, memory limits, and also making everything GPU compatible is a pain. So, yeah, it's all CPU based. Which, for game engines, they're mostly... Depending... Most cloth simulations in games don't affect the actual gameplay, so those are GPU. Those are just... Are they I should learn about those things more before I talk about them. But yeah, we can see that happens, and it is beautiful. Guess I should figure out how to make my own effectors. So let me go and reset this file real quick. Well, open. Don't save that. Let's go and reset the file and then go and move some of our parts into here. So I don't want to edit the main setup. I'm going to go and... Wait, okay, all that's good. Let's go and move this to new collection, demo 1. Move both of those into there. I'm also going to go and chop out... no, that's fine, and that's fine. That's other sim. Chop out you and you just to speed things up. Turn that off. New collection. Let's go and use a new ecosphere. Turn up the subdivisions a few times. That seems to be good. Let's go and add in a cloth. Dynamics. Put in the effectors, which this will be effectors. Go and drag you into there. Name you Lighter 1. Let's go and do that, and then for, yeah, it's that simulation effector. To be a collider. Now, is that a typed... Oh, okay, so we have that. They use a delimiter and they do all that, and then they set a geometry bundle. Yeah, this is something. And then this is the actual effector, which is another typed bundle. I need to figure out how this actually works, because making custom ones, it's complicated. And then there's a viewer, which is unnecessary at this time. Okay. Let's bring you over to here. Let's make this one a set collection. Make it blue, of course. Okay, blue. Effectors. What color should the effectors be? You'll be purple. Yeah, you'll be purple. Green. You'll also be green. Yeah, that's good. Let's go and save this. The demo. For a custom effector, how do we make that? Do I just copy the colliders setup? I want to make my own XPBD sim, and then also my own custom effector. Let's start with the custom effector because I think that will help with the other setups. Let's go and add in a new geometry node. So let's take a look at the collider right here, which you should not be green. Let's just remove that look, and then with you, we'll set this to be green. Reset the sim. Does... Wait a minute. The material should... Ah, right. There we go. It's good for... Uh-oh. I think it just auto-saved, which caused a lag spike, I think. Is it known if the hair sim will be merged into 5.2? Also, congrats on merging your list node. Yes, I'm so glad that node made it in there. I'd say there's a good probability that these will make it into 5.2. This is a real big heavy hitter. A big crowd pleaser, I would say. We still have, I think it's like 2 weeks? 2 or 3 weeks until 5.2 goes into beta, which is a feature freeze. No new nodes, no new anything else. Just bug fixes and stuff like that, which I believe these setups can still be modified because they're not new. The XPBD and all those nodes are already in. It would just be modifying what's currently existing. So I think this could still go through quite a few iterations before the actual release. So I'd say there's a good chance that makes it. Though even if these node groups don't make it, I really hope that the XPBD sim node makes it. Because even though it is extremely complicated with the typed bundles, the 15 bajillion closures and repeat zones, it's still extremely powerful and pretty performant from what I see. So here, let's go and take a look at the 15 bajillion node groups. So we have velocity step, which is one that I made. Edge length, apply geometry cache. Yep, let's go and look through all of the... Oh my gosh, there's so many. Project damping, edge length, evaluates. Object effector. Let's see. Let's just type in effector. Pairing effector, collection effector, set simulation effector. So I'm assuming that's this. We don't need the geometry in there. We just need the effector. So for this, we need to use a combine bundle node. Which this is a... Actually, for the set bundle... Or, store bundle item. Did this have the ability to be a types bundle? Probably not. Before these, I think the way this works, which is still, it feels a bit weird compared to everything else. We have this, and then we name this typed, which is very weird. Wait, oh wait. That's how it was done in the past, but fill items, define signature. Or maybe it's just type? Ah, there we go. It's weird. It's weird. You put in type, and then it changes the name changes how this is actually handled. So, with this, we can go and select whatever thing is here, which I really like. I really like how there's just, like, general Blender types. Lighter pin, edge length, damping, pin constraint. So this part I understand. Collision contacts. That is interesting. Oh, not much in there though. Maybe that's like a work in progress thing. There's a collider, infinite plane collider. In rotation, edge damping, but is there... These are constraints, but I'm not seeing a general, like, move effector. Or wait, maybe effectors aren't a part of this. No, that's incorrect. How do you actually work? How is an effector actually created? So in here, this is a blender collider, so that is the type. The geometry is put into there. Friction, damping, and all that. Okay. So this shouldn't be an effect. Well, no. I need to check in the PR. Does anyone have a link to like where the demos for these are? I know I have some nerds in the chat right now. Let's see. Oh, Jax. Jax is committing stuff to main right now. Oh, it's the weekend. That's cool. Let's see. Where's that thing? Also, Jax, if you're watching, I am so sorry I am butchering your setup again. But it is quite cool. It is quite cool. Let's see, let's go and try to find the XPBD branch. How are effectors created? Solver node experience. No, that's not the right one. XPBD. No, I need to look at the closed one. Physics solver, experimental hair. Okay, so that's the approved one. Are there any demos in there? I also need to play again with the transfer attributes node. Because that is very, 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 very cool. And compatible with the node I set up. Let's see. Have you seen the film grain compositor node? It's huge. Oh, yeah, when it first came out, I took a look inside and I was like, oh no. It also had an issue where in the real-time mode, it would be completely glitched out because of the half precision. Though they did fix that. It was just because they sent... When they had the Voronoi texture, they just added a massive value to it, so that would be like really, really random. But it was too far for the half precision. We need an XPBD tutorial or getting started. I need a tutorial for that because dang, this is complicated. So for this effector, how is this done? How is this done? Because if I can't figure out how to make a simple like general noise moving this thing around, I can't figure out anything else. So again, right here, all these bundles are being combined. These effectors going through there. There's a collection effector. Where's the gravity? Gravity should be good. Here it's a force. Okay, so here's how we go and set a force. And then this is, again, the management stages is, yeah, the management, that's what trips me up. Vert space. External force. There, so it's an external force which is stored on... Is this the original geometry? And then... There's a sample index thing happening here? What is going on? That. Is there a sample index needed here? It transformed the geometry. Let me do... Store a blank force. And they also transform the force. And then there's a named attribute which gets transferred into there, and then that gets added into there. So even for the gravity, they're sampling a copy of the mesh, And that's going into the external force and then into a closure. And then that goes into here as a force accumulation stage. So that's something I'll need to do. And then that bundle gets put into another bundle. Actually, let's take a look into here. Gravity bundle. This bundle is that. And then that gets put into here, and then it gets put into there. And then it gets evaluated by this, which puts it through all of this. And then it gets put into a closure, which goes into this, which gets evaluated by every sim geometry, which is run by this. This is a lot. This is a lot. And then it gets all the bundled nested world items, runs it through here. Wow. This is really something. This is really something. Though it's still easier than actually looking through the XPBD code, which I only briefly looked at, and I saw it was 3,000 lines, and I was like, I don't have time for this at the moment. But I really should look through it. Then removing the sim attributes, which also is a bundle and a closure because it needs to be for each sim geometry. This is incredible. Wow. For each typed bundle, which uses a repeat zone. For each typed bundle uses a repeat zone. That makes me wonder how versioning works with all this. Because for each bundle, list item or bundle item, all that, this is so complex. Let's go and copy the gravity. Place it into here. Let's make it so that the gravity will just work. But that's setting this as an effector. Let's turn off gravity. Wait a minute. That just automatically works for some reason. Okay. Why does that work? I don't understand why that works. It doesn't have a name. It's just technically an effector with no name. It still works. How much can we remove from this and have it still function? We put this into there and that into there. That. Why does that work? Wait, no. It doesn't work, okay. So, there's a store bundle item. The levels to this, I still don't understand. So we're storing an effector into the bundle, which the name internally was simulation, or no, that's not right either. It should be effectors/simulation, which I believe that makes another nested part to it. So let's go and get a string. Also, I absolutely love the new string things here. I don't know if there's a PR to make this also occur in the modifier in the panel here, but that is, even if it's not there, this improvement is still absolutely incredible. Vectors/thing. I'll just type thing in there. So if we do that, plug this into there and that into there. Let's make the simplest effector possible. That does not work. And there's a delimiter. So effectors, the delimiter is, that should be fine. There's no name there. So it should just be that. If that occurs, and then the item, correct. Wait, no, but this should be a new bundle, right? Or maybe we need to get the geometry. This is complicated. Get geometry bundle. So we do that and remove it. We're effectively replacing it. So so that works. What is inside here by default? Nothing. Viewer node. Yeah, there's nothing in there. Snap function. According to Brecht, he only knows Houdini as an exception, but that... Oh, there's a conversation going in there that I completely missed. Whoopsie. I need to read up on that. Sorry, everyone, for missing your grand conversations. Go and take this out. I also want to know, which parts... Okay, so changing the effectors does not automatically update the cache, which is actually a good thing. Don't want that changing everything on the fly. But this does work. Having just effectors slash does work. But if I put anything else in there, it doesn't work. So it just needs to be classified as an effector, and it functions. If it has an actual name, it doesn't. Wait, what if it has nothing? It has nothing, that doesn't happen. If it has that, it immediately does have something. If it just has the name effectors, it still does something. Okay, that is interesting, but we're getting there. Then here, we have that level, the mass, and also that goes into there, and then we have this closure, which also has this, which is a typed geometry bundle. And it needs to be a geometry stage. Okay. So let's go and get a combine bundle. We're trying to reverse engineer this and build it from first principles. String. And put the type. That's still the one thing that confuses me, or feels it kind of confuses me. Where with bundle items, they should be able to be anything, and then there is an exception with the word type. It's a new rule that I need to remember, because it is interesting. Geometry stage. Where is geometry stage? Wait a minute, what are you again? Force accumulation. So the stage is force accumulation in all caps. And then blender.geometry stage. Take a look in here. Blender.geometry. It's not in here. Blender.geometry stage. That does not exist in there by default. Okay. Interesting. Very interesting. That also means it doesn't update automatically. Intriguing. Most intriguing. Why does it work? Why does it actually work? And there's the filter and the tag. Actually, you know what? It's gonna make this easier on myself. I'm going to just go and ungroup it. There's force accumulation. Just go and chop that out, put it there. No, none of that and none of that. Also, the ungroup operator is very nice nowadays. We have all of that. So no, the geometry stage is a custom one. Custom type, and all these parts are custom. Then the closure is what actually matters. So if we go and get a closure, I think I'm starting to get it. Just a little bit. There's nothing in here. I think that's the part that confuses me the most. There are these two parts. There's an input here. Whew, this is something. So this closure can be anything as long as it has a geometry input, I think. There and there. And if this is nothing, this should make this disappear on first frame. But it doesn't. No, it does do that kind of... Oh, maybe that's why it's sampled. It samples the what happens on this version of the mesh. Yeah. And now I can apply the external force. We're over an hour and 14 minutes. Wow. External. Wow, my type. Wow. External force. So now we can actually affect things. Great. With all that, we applied one change to the geometry. This is technically an effector, but what if? No, and it needs to be put into the effectors bundle. Or, no, wait. No, it does need to be put in the effectors bundle. Okay. So all in all, this isn't too bad. And again, this complexity is not due to just geometry nodes in general. This is due to this simulation setup in general. That's why I want to try making a simple version of the XPBD simulation as like a learning step, because this is a lot for even me to take in, which means little Timmy will have no shot of figuring this out. But again, with these setups, these are meant to be finalized assets. You're never meant to look inside of these node groups. They're supposed to just work, in the famous words of Todd Howard. Yeah. The external force gets plugged in, you know, adds to the velocity, I assume. So we just need this external force to be pressure, or just a rotation. So if we take the position, which may need the, I don't know, is this position? No, this is a closure. We're just porting a closure into the setup. So this will use the global space position of the thing. If we go and cross-product it, or better yet, use the average, build average, Control S, just to save. If we go and do that, subtract, plug in the mean, do all that, normalize, of course, so that we get just that working as intended. We do that. We can, yeah, we could either just make that bigger or just do that. That's a bit better. So now we have our spin force. Now, if we do this, we can see, without any modifications to the input, that's really funny. That's hilarious. And then we can turn on tearing. Beautiful. Okay, it looks like we need to turn up, and then, boom, there it goes. So now, without any modifications to the actual cloth group, we can add in general effectors. Let's see, I will read the chat, sorry everyone. And we still have 48 people here, wow. I hope this is educational. Breaking new technology and all that. Look at this, yeah, that is such a cool shape. This is... Well, maybe I shouldn't talk about AI right now, but this is what I like. This is what I like. Actual physics. Actual logic. Not just regurgitated results. Anyway. Yeah, this is fascinating. That part breaks first, and then everything else goes. We have the collider and then the plane. Oh, and also, I saw one of the devs was kind of looking at adding in geometry nodes modifiers to empties, so that I'm assuming these effectors could just work without needing like just a plane and geometry data, you know, latent geometry data in there. Just have empties with the geometry node modifiers, and then it works, effectively replacing the old force fields that we have here. Which it would be amazing if we just have a completely generic version of these force fields. That's amazing. Being able to add in as many as we want, adding in custom force fields. That is incredible. Making it just such a procedural and customizable physics system. Fascinating. Absolutely fascinating. This is what I enjoy about the geometry node side. Playing around with physics. A nice little sandbox that I can play around in. And also make money with, because this is my job. Not this part, but you know what I mean. Look at that. How much customizability. Okay. So we have this, it's functional, it's a geometry stage, it's a force accumulation geometry stage. Which means I can do anything I want in here, but I assume that this stage just tells when this happens, whether it's like before the velocity gets applied, after, or during. So I could make this split. Yeah, let me go and read the chat now as we just watch this loop, this complete tumultuous spinning thing. Okay. Any physics need to be calculated sequentially, and CPUs are better at that. Since this is step by step, and CPUs also use 64-bit precision math. Yes. As far as I know, Blender doesn't actually use 64-bit floats, part of why it isn't ideal for CAD work. Oh, I didn't even know that. I did not even know that. Meshes and transformation or everything. I don't know. I just remember seeing it mentioned by a dev several years ago. Interesting. I did not know that. We need the tutorial up. I've read that. I just read that render softwares like Blender Maya use 32 bits, or else it would be very heavy. That makes sense. CAD looks simple, but it can use 64-bit for meshes and transformations. That makes sense because with CAD, you need things to be as precise as possible. New string input is great for adding quick notes in a node graph. In my opinion, it's the best way to document a large node tree. Yes, that's why I was the happiest about. Just like, I can actually write in documentation on these huge things so that whoever gets the node group next doesn't need to look at 5 reroutes in a line. And I do, again, I hope that we get that string expandability in here as well, so that we can have documentation in here, just a panel with tons of documentation if it's needed. Though I assume that would be a bit more complicated because, you know, it's like what is it? These string inputs need to be in line, while the string inputs in here do not need to be in line. So it's a balancing act. Maybe there's like a flag that could do that. But anyway, that is just like a UI item thing. A UI thingy-mabopper. Wow. Okay, so we have that. Now, I think after we got through that hurdle, it's time to go into another hurdle. Actually making a simple XPBD simulation, as basic as possible for educational purposes. I'm not sure if this will be successful, because as we saw with this setup, and even with the hair, it's funny that the hair was the main feature and we're all playing with the cloth simulation because it is a bit simpler to deal with. As the hair, that is something else. Because with the XPBD solver, we can see in here that it by itself isn't too bad. Just the beginning and... Oh, because of substeps. Or is it? Because the substeps here happen with iterations because it needs to deal with everything else in the world. But no, even... Wait. One at a time or all at once. Oh, that's interesting. Okay, we're just gonna ignore this part. We're just gonna deal with this. So this is fine. Interpolation range, I assume that's just complicated stuff internally. But it relies... in an earlier iteration, it was just geometry in, geometry out, and then the stored data on the geometry. And then like tons of inputs. But now since it's a bundle, that is what confuses me, because this bundle can have anything. We'll say that is updated by the solver. This can have anything inside of it, and it can update everything. So we have that. I can't, oh wait. Oh, we can't look at this with the viewer node because it's not packed. And, because it's inside of another node group as well. Whew, okay, let's go into here. I'm confusing myself. I'm going to reset this after I figure out what's going on because I want this to be not affected by everything else. So I need to go into here, show hide, node options, do that. We go into here, take a look at this. Then we look at this in here. Let's take a look at the viewer node. Okay. We just need to reevaluate that. So, oh no, oh no. Oh no, oh no, oh no. Oh no, oh no, oh what that? Is, what? You know, I have a feeling. I have a sneaking suspicion that that should not be happening. That I highly, 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 highly doubt that this should be stacking every single frame. I highly doubt that. This is why it's experimental. But also it goes to show that the management stages are, wow. So there's just a bundle item that is stacking the previous bundle item into it. Oh wait, maybe that's because of my bundle. That might be because of mine. So if we go and turn it off, does that still happen? That may be because of mine. Nope. Still there. Still. Oh, and it's not. Cloth Effector 1 and Effect. Wait. Is that still being considered? Move it completely out of there. As far as I know. Yeah, no. Okay, so the effectors are causing. So it's not just me. The effectors are confusing, even to the setup. Unless I modified something. I don't think I did anything. So, effectors previous, and then it keeps stacking the previous effectors. This may be why. I'm amazed. I'm constantly amazed that this is performant. Because even with this happening. Then in this bundle doesn't see it. This bundle does not see it. Yeah. It looks scary at first, but it's all previous. Yeah, I know it's the previous steps. But I don't, this shouldn't be stored. There's only so long a string can be, and I'm assuming it's already getting to there. If this is running for like a 1,000 frame simulation, that is not. It has to be just a little accidental. Oh wait, I stored this after. Because it probably should just be effectors previous and then not stack, but for some reason it's stacking. Cloth edge, length type, length filter, compliance, length. Okay. Cloth damping type. And then filter positions. So where's the actual geometry? Oh, of course, it's after all the cloth slash. Okay, it's cloth slash geometry here. Weird. Okay, but I get it. It's cloth and then. Okay. No, that makes sense. That makes sense. So there's cloth, which is the main bundle part. And then there's the part stored inside the cloth bundle. Okay. So what I need to make, these are typed bundles, right? I think. Cloth geometry. And then there's the apply geometry cache. I'm not going to worry about that either, even though I will figure out how this works, and I will get the most basic simulation working. I will. Okay. Now that I kind of know what's going on, and that there's just a wee little bug in there, either induced by me or just native in the system, I'm going to go and reset the file. Okay. We have that and that. Okay, let's start out with a new sim. New geometry node. XPBD. Simple XPBD. It's not going to remain. Going to do that. That is demo 2, and then new collection. D3S for demo 3 simple. It should give them better names, but oh well. Don't save this in its current state. So now what we want to do is have a simulation zone. Let's expected. And we do not want the geometry input because XPBD, we actually get the solver in here. First actual solver, we put in the world and we output this world, and then we get... Right, there's that node as well. Get bundle item. We have that. This is going to be geometry. So we're going to harvest the geometry once we figure out how to do that. Substeps 10, constraint iterations 1. That's fine. We go and plug in the delta time. So now we need to figure out how this actually functions. So we either need to store a typed bundle. So combine bundle. Oop. No, node. Again, bundle item needs to be a string and then needs to be capital T type. Now we have a type. Now we have all these parts. But no, they're not going to be that yet. We will need those. And we will need a join bundle node. Very complicated. I think this is a result of just node editors and data that needs to be this encompassing. Like, we need to pull data from these disconnected objects, this and that, and then making it work in a node-based system. It's a complex endeavor. But we're getting there. I will figure this out. I will figure it out. I just need to check something on the side here. So I'm assuming that... Nope, that's all good to see. Just checking a few things to see if I missed anything. Oh, wow. Look through a lot of that. Anyway, let's get back to here. We're still at 49 people. Hello, I hope this is educational more than it is confusing. Previously, wait, let me get my voice right for this comment. Previously on XPBD, previous. Yes, that works quite well. Let's see. You may be interested in this. In cloth dynamics, you can add pressure by applying a force to the effector. The force should be the surface normal scaled by the pressure value. Wait, it's just the normal? That's how pressure works? It's just the normal. I did not know that. I thought it was something a bit more complex. Just the normal. Actually, that makes sense. Yeah, that does make sense, doesn't it? I was using the average. And also, because we have the effectors here, my custom effectors, I could just go and read the position, scale, and then put it into there. So right now I have the spin force. I can go and just, apparently, with the normal. If this is how pressure actually works, I can just do that, and then boom, pressure. Pressure, and then spin. If that's all that needs to happen, then boom, new pressure force just like that. Though I think in another iteration of the cloth thing, they would just have it internally. If tearing exists internally, then that can exist. If it's that simple. People have done a lot of very cool things with that. Okay, so the types bundle. How do we put in the geometry? Like with this version. Look, let's also wonder if in a future version of Blender, the hide and viewport icon will just be merged with the disable thing. Because there's probably a technical reason for this, but if I'm just giving unsolicited advice, those should be combined into one. It's always confusing. Okay. Right, I tried doing this before. So here's the actual geometry data. There's setup structural rest data, which as we can see is confusing as heck because it is node group after node group after node group after node group. I am 3 node groups deep. So, and I'm assuming these are node groups for future versioning. Store segment length, rotation, and all that. So all this is just stored. Whether it is a mesh, curve, or grease pencil. Oh, you could do hair simulation on grease pencil. Cool to see, cool to see. Won't complain about that. But nothing for the point cloud. I wonder if point clouds are supported in the XPBD. I know self-collisions are probably not. But they're setting up that data and then converting the space to be in global space, of course. Setting the radius to be the collision radius. Not using the built-in radius. So it could probably just port that into there using the node group UI. Storing the position and sending it into all the other parts right there so that there's a consistent position being sent around. Though, yeah. Also, with the hair simulation, I'm starting simple with the cloth simulation and then I'll move to the hair sim. Because for the previous cloth simulation things that I set up, I just stored a rest position attribute. While with the XPBD solver that they have, they store a copy of the mesh, which I think is probably better because they don't need to reevaluate the stuff every single frame. They could just have the rest mesh and then call it a day, which is good. Then setting the geometry tags, which in this case, in terms of tags, we have no tags, which is good. We don't need that. Setting the friction, we don't need to deal with that. And those are just stored named attributes. Oh, back to simplicity. You love to see it. And then there's the set geo updater, which apply geocache. This uses the transfer attributes thing, which I'm assuming, oh, wait a minute. And these are IDs, not indexes. So I'm assuming it can transfer those between different, I know this doesn't make tearing possibly because the split edges do that by default. Though they have different topology between the split and the original mesh. So no, it does still work. Yeah, this node is fantastic. And then also with the get attribute names node, which I can't add into there, it's incidentally fully compatible with this, meaning that you can transfer every single attribute, including position, which you would have to ignore. Or no, maybe not. What was I saying? Right, you can transfer every single attribute from one mesh to another, solving a big problem that was with previous setups. The inability to just transfer every single attribute like the, what was it? What was it? Like the built-in nodes. But yeah, we have that. So this can be skipped over. So this is the part. We combine the bundle, which is just geometry. And then that's put into here, and then that's put into here. So it seems like geometry just needs to be put into there, and then it'll just be fed into there. Then you get the bundle item, which is the cloth geometry, which I missed because I think I was looking at the hair simulator last time. If I, nope, that's the wrong one. I should have the effectors up here instead, yeah. Here, we can go and get, well, let's copy that in there and call it a day. So when we put the geometry into here, it'll come out as that. I did run into a crash, I think, when some of this happens, so I just need to, so I'm going to use the get and store bundle item method just because it's a bit more reliable in my brain. Store, bundle item. You just have, or just label it A. We'll go and put this into here. I just want it so that it passes through. And I can actually see it at the other end. Saving again. Does anything pass through into there? Up that. Bundle path not found. Okay. Because, yes, this needs to have the name geometry, of course. Needs to have the geometry. Still not found. Is it because for the setup it combines it? So if I do cloth / geometry, give it another word. Okay, there we go. So it needs to be in the cloth category. Well, for it to be found, but I'm wondering if that needs to be in here as well. News hair sim test is there. Thank you so much. Danke, danke. All right, because it doesn't let you put links into here. Da, 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 da. Just looking around there. Okay, I think I... Uh-oh. Uh-oh. I got an update for the scene time node. They fixed... Oh, wait, Brecht right now, 30 minutes ago, fixed the OSL. Oh, cool to see, cool to see. And is running another test. What was the actual fix that was needed for that? Thank you so much, Brecht. Devs have been so helpful with all the nodes I've been thinking up. I do worry sometimes that due to my inexperience with coding and all that. Oh. Okay, well, it seemed to be in the wrong area? And... services shared. Oh, okay. I forgot to put in the scenetime.osl thing in kernel OSL shaders CMake lists. Rookie mistake. I do worry that with the nodes that I make, I get the ball rolling and then I just ask the devs to review until it gets refined, and then they end up fixing some of the issues and then they get implemented. Though, I hope I'm doing a majority of the work rather than making them do all of it, because with some of these features, well, quite a few of these features, they never plan to do it. So I hope I'm not adding to their workload. But cool to see. So if those tests work and go through, there is a chance that the scene time node may make it to 5.2 this week. Next week. Today's Saturday. Hair beam stiffness. Should I get that one? The female hairstyle simulation. Yes, let's go and download that one so that we can test it. So here, again, we have the cloth geometry. I want to test if this can just be geometry. I'm assuming not. If I reset... It does pass through, and it does set the velocity. Okay. Why did that crash before? So with this, can I set the effectors? Because if I go and store name attribute vector, have this be velocity, in theory this should move. So this might be a lot simpler than it moves. Okay, so that works. Right now we have XPBD simulation just working by default. The complex... Okay, so this is the simplest way to get it working. You just store geometry, send it through, and then get it. Can this be something with an arbitrary name? I'm assuming no. Yes, okay. If it is a mesh, it will apply it. Cool to see. Okay, that is good to... Okay, so it's not nearly as complicated as I thought it was. It's just applying dynamic forces. Because right now it's not stacking them. I need to find a way for these forces to be updated on the fly. That is the part which I think may be complicated. Okay, let's go and take a look at this. Should we take a little break, a chat? Oh, we have 54 people here. Hello. We take a little break and take a look at the proper hair simulation and then come back to this now that we got the first simple setup for a basic just moving points in space simulation working. Because I think the next stage will be adding in either closures or something worse. Because for the velocity, actually let's do one more stage. So right here, I'm going to try to keep this as a no node group setup right now. So here we're going to remove the geometry and then store the geometry. I do worry about these stages having a performance impact. But if we do this, this should, oh right, because I'm not stacking the velocity. This should be the simplest example of adding velocity. So if we wanted, say, gravity, let's do 9.81 meters per second, negative. This should cause... That's a bit too fast, don't you think? Probably shouldn't... That's a bit too fast. I didn't get every frame, so oh, right, I need to... Plus, delta time. I keep forgetting about delta time. That's a thing. So if I went and did that... Does that work? Oh, no, it does work. Okay. So we have stuff flying up and then going down. Okay. So now with this setup, this is the simplest way of getting the XPBD to work. Now you may be wondering, why do we need to put it into a bundle? And then take it out of a bundle and then do some stuff and then put it back into a bundle. We need to do this because there is so much more data that we need to, as we can clearly see right there, which the tooltips keep accidentally helping out so much. There's so much data in there that just needs to be put into there. Now, I don't know, I think in previous iterations these were, well, no, it still has the named attributes as well. But there's a lot of, there's a lot of stuff going into there. A lot of stuff. So in theory, this is the simplest thing there is. Now, I assume that there are no constraints on this whatsoever, because again, this is just a simple setup. If I do this, let's go and chop out the original velocity there. This will just expand and expand because there are no constraints. So how do we put in constraints? That is the question. In theory, do we need to store... I'm going to be using store bundle item again because it just feels more consistent and reliable. Stretch shear constraint. We have the rest length and the compliance. Put that in there. But does this need to evaluate? And then the lambdas. I actually forget what lambda means. It's, as you can tell, it's been a while since I've been looking at physics papers. Or any type of complex math whatsoever. I just look at the lines and boxes and call it a day. Yeah. How does this work? Does this actually need a good bundle? Oh. That's because my custom, are right here. Because the closures are all funky. No, not that one. Since the closures don't automatically update, they can't automatically update because the stuff is being portaled everywhere. And I assume if there's corrupted data, that would also make it the heck out. So in here, I just need to copy simulation to world. Cannot copy. I know how to spell. I went to school. Maybe not a good one, but I went to one. Let's see. Simulation to world. Simulation to world. And, oh yeah, they are using capitals. Maybe I can spell, but my dyslexia is getting... to world. Okay, that is good. That should solve all the errors in the sim here. Yep, no errors. So that'll show if you have a corrupted force field there. Go back to here. So there's the edge length constraint. It's labeled edge length, which doesn't actually need that name. That is the question. Edge length constraint. That has that, and that. There's the rest length, the compliance. Okay, so joining that in theory should just work. Or just storing the bundle item. And then it just needs A. Just need to store it as a path. It's not doing anything. The rest length and then the compliant. Let's go and make this a bit less effective because I want to see. That's the strength and shear, while I need the edge constraint. That, and that does work. Okay. So, wait, why is it collapsing in on itself? What we learned is that it'll collapse in on itself, and is it because it doesn't have the actual stored attribute? I think so. Because if we store a bundle, this is just one value. It's not storing the attribute. It needs the attribute. Or does it? Let's take a look at the internals right here again. Custom length. Ooh. Now this takes the attribute, puts it into there, so that's not a problem. Is it the compliance that's the issue? The compliance is set to the power of 5. Okay. Okay, I'm assuming that's just some technical thing that I do not need to worry about. So we have that, we have the damping. Which... anywhere, once I get one going, I'll be able to get them all going. Doesn't need... Where is the... Where is that stored? Rest length? Ah, there we go. So that is just a stored attribute. That is good. Still trying to go with the no node groups route. So I just need an attribute. So this will be rest length, just so that we can update that in the future. But how does the named attribute go into there and work in there? Because that doesn't make sense to my feeble little brain. Why would this go into there, and how is this referenced by that node? Because the rest length here, it doesn't compute. Instead of, with the named attribute there, this uses this, this node, the XPBD node, does it use determined attributes? I think it does, but it also needs the bundle to determine, to like enable, yes, this is being used. This confuses me. Am I stupid, chat? It's doing something, but it's collapsing in on itself. At least it's doing something. At the very least. I assume the compliance value default is maybe not what it should be. Maybe not. What's the compliance on you? Structure. Damping. Linear damping. Oh, no, that's that and that. Oh, they do have bendiness. What am I talking about? They have that. This wasn't in a panel, so I didn't see it. Yeah. So we don't need to worry about the compliance right now. We can set that to 0. Do we need a stretch and shear constraint? And all this needs, if we go and eliminate U, yeah, it just needs a name. It's still it confuses me. Should... No. Okay, filter local, there should be no filter. With this all here, let's put these into frames so that I can actually somewhat track what's going on. it's a different workflow than just the geometry and attributes method, because there's so much, I guess, metadata that is around there. So if there's a shear constraint, we go and do that. We don't need to worry about those two, I don't think. Unless, let's go and take a look at our reference that we're copying. Again, we're just trying to get the most basic setup in the universe. Where's the stretch and shear, damping, bending constraints, cross edge. Need that one as well, which means that we also need a rest position, damping in there, and then, no, that's for hair. Okay, so the other one is for hair. What we need is edge length and bending. We need those two stored. So let's go back to our little reference here, or thing here. We need the bend. What was it called? 3 seconds and my attention, my memory couldn't even hold it. Cross edge length. Cross edge length. Cross edge length constraint. Refresh that. We can get the rest position. So let's go and store our rest position. This is complicated. Rest position. Just make it the position. Put that into there. And then we just plug in another named attribute into there, which again, that's what confuses me. These bundles are not connected to the geometry path. So how are they actually being implemented? And let's not forget to label this B, because we just, you know what, we're foregoing capitals. We just need A and B. So, if I'm correct, it looks like something is not occurring. Okay. Probably because it is just where it should be already. The thing I need to figure out is why that is occurring. Question is, why is it collapsing in on itself and not doing anything? We got the rest length. The rest length is just that, which edge vertices. Again, we're going with the no node groups route just to keep it a little bit simple. That should be on the edge, of course, of course, of course, of course. That may be why it was freaking out. Nope. Should be on the edge domain. The rest position should be on the point domain. Hey, how are we doing this fine Saturday? We're trying to reverse engineer the complex XPBD's cloth solver. What is actually happening in there? That the devs made. I'm trying to make the simplest version so that I can learn how it actually works. Though it's a bit easier said than done. It's not a complex setup right now. The most complex part is just getting the geometry from the bundle, recombining it, and then putting it through there. Though, it's just finding out like how it actually works with these typed bundles, because the first XPBD solver was just geometry in, geometry out in the world. That wasn't too bad. But now we have bundles, nested bundles, and then typed bundles included, which adds a lot to the complexity for my brain. But I will decipher this. Will decipher it. I will. Because we have that and that. So the edge length constraint, there definitely is something going wrong there. That's what we know. For some reason, it wants to collapse into absolute nothingness. Which means that it's trying to find something that isn't there. I'm assuming the rest length. Nope, even with that, it is still finding nothing. Spelling is correct. Let's go and look at our reference sim again. Again, we're having this much difficulty copying from the open book test. Okay, we got rest length. Oh, that's on the point domain. Oh, no, wrong one. That is on the mesh. That is edge. Okay, good. Then in here, yep, it is just distance. As intended. Then we switch land to there. We get the radius. That's fine. We store the position. We've already done that. Setting the geometry tags. In terms of tags, we don't need any tags. Setting the friction. We don't need to worry about any of those just yet. Applying the sim cache. We don't need to worry about any of that either. This part is funny. Because... So, yeah. If the tearing is enabled, then it goes and does that, which is also amazing. Could have the other node for that. Don't recognize half the nodes. It's because they're like, how many node groups do we have in here? Inside the blend file, we have, 4 node groups. Nice. In terms of the ones that we got here. Why are my Gumroad products in there? In terms of this one right here, we have, nope. Just one. Yeah, 53. 53 from the linked data, which is nice. That's a lot. It's too much for me to go through with my brain, so I'm trying to recreate it from, not scratch, but nearly from scratch. It's there, like we don't need to worry about the pin positions yet. That seems to be pretty easy to deal with. That input there is just from that. So with these bundles, they are connected to the original geometry. So if I understand this correctly, the purpose of these bundles is to just reference different data, because we can't store constants on geometry. We can't store single values on this geometry. Wait, I think it's clicking in my brain. This is like storing instance data and then storing data on the actual vertices of the geometry data of the instance. So all these bundles are just to store constants. I think I get it. Do I get it? So no, but we can't store constants on the geometry because we have the set geometry bundle. We have geometry, we can store stuff in the geometry bundle, right? But there can be multiple layers of geometry in there. Because, no, it has to be separate because we can have multiple geometries being fed into this thing. But we need constants that are separate. So these bundles are just references to data on varying meshes. And also constants. I think I get it. I think I get it now. So when these are just referencing, all these bundles do, if I have this correct, they're just referencing constant and attribute data references. And then the actual attribute data is on the mesh. So all this complexity is solely for management. I think I have that correct. All this is just for management of the data. And then the actual geometry holds all the data. And then all the management gets processed in here. So the complexity is due to the processing, the management of the data, not necessarily the data itself. I may be completely wrong with that. Also, I don't know, do colons do anything? No, I don't think they do when it comes to storing named attributes. I also wonder why this is cloth/geometry. Unless inside... Oh, no, that's because of you, of course. The effectors just go through another line of data. Yep, that makes complete and total sense. Now the question is, yeah, no, those are not closures. We don't need to worry about those. And there's the tearing effector, which is a closure, which we don't need to worry about. Then the cross edge length constraint is there, and then that gets stored. So in theory, this should be working. The problem that the The edge length isn't. That is the problem. Is it because of the softness and the compliance? I hope not. Because as we see with this little guy up here, having a grand old time. What is your problem? Because these two go into here. And do I need to label this as cloth for this to understand that it is cloth? That is something... Do I store this entire bundle under cloth? Put it in there. And then we would need to do... It won't read because straight up missing. This should be cloth/geometry. We just plug that into both there and there so that we can actually get it. No, okay, same result. Not bad, not bad. That means we can just skip over the nesting right there. You love to see it. We're at 2 hours right now. I think... Okay, I think this is going on for a bit too long. At the very least, I'll need to split it up. Maybe I'll do a stream tomorrow if I have time. But let's take a look at the demo, the hair demo that the devs had. Open as a nice thing to top it off. So we're getting there. I just need to figure out a few things off stream. Do downloads, female hairstyles. Oh no. 13 linked things are not working. No, this has not been updated. Oh, okay. Well, we can yep, we can see oh. Interesting. Oh yeah, guides. That's another thing that I need to look into implementing. Once I find the thingamabopper, once I figure out how to do the hair simulation properly. Because I have a setup for making guides work. I use that a lot. And that's very necessary. You just simulate, that's just a thing you do in production. You simulate the guides, the rest of the hair just follows along at render time. Though, oh wait, no, this is the same model that I used. Do the curves have the same density? Yeah, it looks like the curves have the same density too. Yeah, so why would that one be... Whoa. Oh, no, that's just the roll hair curves. I keep forgetting how complex the node groups are. Maybe my node groups just aren't that... like... Not effective. My node groups just aren't that complex, on average. I'm just not built like this. Let's see, yeah, okay, so I'll need to find an updated demo for all of that. I assume the devs definitely have their demo files, maybe just not readily available at the... Oh. Hello, Jax. Fancy seeing you here. Hello. You honor me with your presence, of course. Let's see. Some fields or constraints need to be pre-evaluated before they are passed into the XPBD solver node. See the commit message. Things might just work if you use the evaluate effector attributes. Okay. Since we have the creator here, let's go and take a look at, let's go back to our test, our simple test. See if we can make this work. Okay, so see the commit message as well. Yes, do I have... Okay, the builds for the scene time node are still going. Oh! Okay. 4 of the builds are done with the scene time node, the shader scene time node. 4 of them succeeded, which is amazing. Where those failed the last time because of me just missing a CMake listing. Rookie mistake, of course. Though in my build it was fine, you know? Let's see. So if that all goes through, it might make it into 5.2. That is incredible. That is absolutely fantastic. Let's see. Do I have the commit in here? Nope, that's the old XPBD one. Okay, let's go and do that, and then I just need to see referenced an issue from the commit, reference the pull request. Okay, let's see the actual commit message. It's a new experimental built-in. Oh yeah, no, I should have looked at this beforehand. At the highest level, this is a new aerodynamics asset, fairly large node group, world bundle. The constraints as I should here. Let me get this up on the viewable browser so that you all can see this and I'm not just yapping into the void. Let's see. Let's also get the... Which one is this? Let's also get the main commit or the pull request in there as well. Let me verify that I am human. I think I am. By evidence to the contrary. Go to the browser. Here we go. Alright, so this is the... So here's the PR for the hair dynamics with all that. There are 909 commits, which is a massive feat. I wonder if some of those are like from merges and stuff like that. I would imagine. Yeah, I imagine that some of those are just from merges. Though if it was actually 900, wow, that is incredible. Let's see. It is a potentially deeply nested bundle, which contains so-called typed bundles. Okay, let's take a look at this. Based on their type, besides typed bundles, it also contains geometries which are simulated. Okay. So the world bundle has typed bundles as well, and the simulated geometries, which I assume that implies combined things. Here, let's also make this bigger for you all. You probably can't read that whatsoever. There we go. Okay, due to their generic nature, just a bundle, world bundles can be composed from other bundles. For example, it is common to combine multiple effectors constraints into one bundle, which is then added to a world bundle at once. Objects can export bundles of the geometry like force fields and other objects, which we took a look at, which can be passed into the simulation on another object. Okay. Constraint types. The following constraint types are currently supported in the XPBD solver node. Mesh colliders. Handles general collisions with closed meshes. Infinite plane colliders. Yep. Damping, linear pin positions, pin rotations. Yep. Shear, bend, edge length. Yep. Cross edge. Yep. Most of these constraints also have a compliance value, which indicates how much of the constraint is allowed to be broken. Yep, that makes sense. Value of 0 means that the constraint should be perfectly maintained. Sometimes this cannot be achieved due to few substeps or constraint steps, or because the way the system is set up makes it impossible. Yep, we've seen that. This is a very nonlinear value. It is generally exposed as a softness value between 0 and 1, although technically there is no upper limit. As it is also named bendiness or stretchiness depending on the context. Other new nodes, you have the transfer attributes. Big fan of that one, big fan of that. Tag filter, I don't know what that one does. A simple node that makes a list of tags and a filter string and checks if the filter matches the tag list. Currently only comma-separated lists is allowed as a filter. Okay. But slightly more complex syntax may be supported in the future. So that can filter a list of strings. Wait, no. Simple node takes the list of tags and a filter string. Yeah, a list of tags and a filter string. Okay. Check if the filter matches the tag list. Okay. So you can have tons of tags and then the string to be filtered. I'll need to look into that, sorry. Everyone currently and all that. Okay. Field pre-evaluation. Okay, let me also check the side here, the side thing here as well. The evaluate effector attributes node group. I'm reading Jack's comment here. The evaluate effector attributes node group is the simulation zone in the XPBD simulation group. Okay. What is the benefit of the scene time node over the current frame underscore current attribute? The one just gets the data directly. So it should be faster and also much better than hashtag frame. Which, the main reason I was looking into getting the shader scene time node was to, one, make... Sorry, my brain is trying to run in parallel with that comment and the geometry node stuff. It was to add in parity between the editors, which I could have done that if I wanted to choose the simple route. Just a node group with that view layer attribute would work. They did fix the little frame update issue that was going on there. And then, yeah, all of that. Let's stay focused on the current task at hand. Reduce before released. Node groups asset still needs to be finalized, especially with respect to the surface geometry and forces. Welcome back, mod. The already existing hair asset needs to be updated too. Assets need to be updated too. The operator to sub hair needs to be updated. Yes. Yeah. Setting up the hair was interesting. It took me a little bit to get the hang of it, but it wasn't too bad. Okay, let's go and apply the Firefox. Come on. Let's go and apply the advice Jax made, sent in the chat. We're over 2 hours, so my brain is starting to run into its memory limit. Okay. So, let's see. Evaluate effector attributes. Right here. So we have all of these. Yes. So this relies on this. Uh-huh. Uh-huh. Somehow you skipped the pre-field evaluation section of the commit message. Oh, I'm sorry. I'm just gonna blame that on time. Okay, let's see. Pre-field. Where are all those? Oh yeah, no, I skipped the one part I was supposed to look at. I am so sorry. Let's see. Okay, so pre-filled evaluation. The XPBD solver does not evaluate fields, does not evaluate any fields itself currently. It instead relies on other nodes to pre-evaluate the fields and write them to specific named attributes for easy consumption. Oh. Oh. Besides simplifying the solver, this appears to be necessary to cleanly support constraints which are interpolated across the substeps like pinning constraints. For those, the solver does not need the current pin position, but also the pin position of the previous time step. Oh, Jax, I'm not sure if you were here for this. I'm not sure if this is something I screwed up or something with the setup. But we noticed in one of the things... Whoops, I collapsed Firefox. We noticed... What was it? That the previous bundle would keep stacking in on itself, creating a really long string. I removed any of the changes I made to effectors I had in the thing, but it still kept stacking, so I'm not sure if that's a bug or something that I screwed up. Either or. But I'll if I find the bug again, I'll make a report normally. Let's see. Let's see. There are two different kinds of pre-evaluations are necessary. Hard-coded attribute names, the solver reads from and sometimes writes to these hard-coded, yeah. This includes position, velocity, rotation, angular velocity, external force, friction, effector-specific attributes. Some effectors, like pin position constraint, need additional attributes on the geometries it affects. In this specific case, it is necessary to know for the current and previous frame which points are pinned and where. in that per constraint or multiple. The naming convention for these constraints is simprop effector. Oh, okay. I'm not saying these ones because I'm trying to absorb the information. It is getting harder as the stream time goes on. Let's see, simprop and all of that. The user is all that. This is entirely handled in existing node groups. Okay. So I'm going to try the existing node groups now, but I have a feeling. I'm not going to say this yet because I'm going to try it. And all that. Get out of full screen on Firefox. Let's see. Okay. So if we look at this, yeah. It's the list items, and then it formats those into here. Does this imply... I'm not going to say that yet, but I have a little theory rattling around in my brain. Which was... You evaluate effector attributes. Okay. Evaluate effector attributes. Effector attributes. Go. And that is before the sim. Let's go and check the open book test again. We have that, it goes into there, and then it goes into there. Okay. Let's see. Let's go and plug this into here. Do that and then that because this actually sets the forces. I know the previous thing is a bug. That's on me. Ah, okay. No worries if it's too complex for now. A better error messages are still necessary, which would make it less frustrating, hopefully. It is a fascinating... Okay. Value not found in bundle rest... Oh! In bundle. Okay, so it does need to have a name. Okay. So, rest length. That's... all that? No, okay. Value not found in bundle rest length. Okay, apply. Again, I'm just trying to reverse engineer this. Though, from the commit message, and from what I see in here, it almost implies that this can... I just need the names. I don't even need the bundles, potentially. I just need to store the attributes. So that will already handle that and then send it through. Potentially. Let's try to get this main thing working and then deal with everything else. It's been a while since I've done a 3-hour stream, but it looks like we're gonna hit that. I don't think I have anything else pressing before a certain time, so I should be good for now. Let's see. Also, Jax, if you're still here, if you need to go and do stuff, I perfectly understand. I took a look at the UDIM stuff, and it is a bit too complex for me. I assume that I'll keep working at it in the background, but I may rendezvous to ask you some questions about it. So what was the point that I was missing with this? So there's edge length. So does that need to actually have the name edge length to be put into there, and does it need to be in the class? So, edge length. Then this is not that. So we don't need to worry about these two. We don't need to worry about that. The length attributes. Let's just check in here. So it gets the typed bundle. It gets the paths. It gets all of those. And then it stores... So it gets all those paths. And then for each path... In this case, there's only one iteration being sent because I'm assuming there's only... No, there may be more than just that. There may be more. And then we get the world bundle item. We get both of those as well. That also gets the world bundle. Those get put into there, and then this just sets the names of those. So these can, in theory, be set on the fly. It's the names that are specific, and then it gets sent through there and ported through. So in theory, if I wanted to reverse engineer this, all I need are these two with the right names. Sim, prop, something, and then that. In theory. Now I'm assuming that the format needs to match the geometry in here. So let's give this a go. And see if I can actually make it work. Though, this is the issue. Where are the errors coming from? Are they coming from... I also really enjoy that we can click on the breadcrumbs in order to get back. That is very nice. Always cool to see. That's right there. They're not found in bundle. So those are just null. No, okay, so it is in there. There are no values found. Okay. It gets the world bundle, and it tries to find these two items. And the item is from there. But no, it should be able to get those even if I screwed it up horrendously. Unless I need to put those into the cloth parts. So maybe they need to be nested in. That's the world, but if I nest these into cloth, just to plug them into there. But it is interesting that in theory, the type part here might not actually be needed. If I can't figure this out within the next 10 minutes, 5 minutes, I'll try just setting the stuff on the fly, which would be interesting if that actually works. Again, a very different, a butchering of the way it's supposed to work. But again, I'm trying to get a fundamental knowledge and then build up from there. So this is me trying to digest apparently 900 commits, which is something. And then that would be interesting in theory if that means that I can skip almost the entire bundle method for this. Again, not recommended. Before this test, I think that might be an interesting... I guess it just shows the flexibility of this. Always good to see. And props, and then the property will be here. So it gets the nested bundle paths. So I need to see what that actually does. Actually, wait, I can, yeah. Can I copy nodes from inside here and then bring, yes, I can, good. So if I go into here, bring this out into here, and then take a look at the viewer. Oh, viewer. What do we see in here? Maybe it's nothing. Maybe that's the... Here we have this, this, and that. Bundle type. Then that gets that, and then... Oh, wait. It's because it's the pin position. What am I talking about? Go into here. We go chop that out, bring it out to here, and we should see... Ah. There we go. It just gets... Wait, what? Get nested bundle. Oh, okay, so that just gets the path. Oh, okay, so that's all that does. In theory. The bundle and pre-evaluated attributes are both necessary. I'm not sure exactly... I'm also not sure exactly it's not working right now. Would need to check the file someday. Yeah, no worries. Again, this is just someone who knows... who doesn't know what they're doing. Looking through and seeing what's going on. Maybe it's because of this going through there. I think either because the geometry is not stored inside the cloth bundle and then it's getting retrieved and doing all that and then being sent through. There are many potential reasons. Maybe it's because the attributes aren't actually stored in there. I don't know. Maybe I should let this sit for a bit, because I feel my brain contracting. What's the right word? Constricting. I'm just refreshing the scene time thing to see if the builds went through. Okay, some of the builds are not done yet, but the ones that matter, that failed before, are done and are working. So in theory, that should be good. That is good to see. That is very good to see. Okay, checking everything else. Hair dynamics. Okay. I think the stream has gone on for a bit too... Oh, wait. I just remembered some stuff of the world bundle is removed when it goes through the simulation input node. Some stuff of the world is removed when it goes... Uh-huh. Okay. Intriguing. Some data does not cross through. Interesting. Very, very interesting. Okay, I'm going to give one shot at taking this stuff in here and then applying it. I'm going to try to, again, with the my philosophy of let's try to make this as simple as possible. We have this here. This probably won't work given what Jack said, but I want to give it a shot. At the end, at the finale of this, just type A and A. There. Yeah, no, nothing occurring there. Okay, yep, that's... Let's just set that to be there. Well, sim is functioning. Yeah, okay. Yeah, no, that makes complete and total sense. Format string, and then the input there is that. So if we inside here, that is going into there. It gets the list item, which in this case there should be only one item, which is edge length. So this should be sim prop, edge length, rest length. And then that gets stored in there. The rest and the compliance go into there. This is the main geometry bundle. Which goes through there. So we get the main geometry bundle. It goes through there, evaluates the closure, sends it through. So, while it does need both, on this side needs both. Needs both. Alright. We're at 2 hours and 30 minutes, which I think is more than enough time for today. Just going to label this A again, so the rest length is going through there. It's not collapsing the mesh anymore, which when we had this... Oh no, wait, the whole thing's broken. Uh-oh. Ah, because of course it crossed through. So that happens, and then if we plug this into there, it works. Why do you work? I don't know. I don't know, but here we are. So it still needs the typed bundle for it to work. Can't skip over that part, which is, yeah, as we expected. And then for that, these don't even have the right name there. It just needs the presence of... This is indeed fascinating. And they don't even need values in there. They just need the typed bundles to exist. Apparently. Yeah, oh wait, it just needs this to exist. This is a... I am very much out of my depth right now. So, in theory, if I wanted to make this even more of an atrocity, I'm going to label these as A. I am so sorry. I am so sorry. And the name of science... that out. Just go and move all that down, move all of you down as well, so that we can have this part right here. Let's go and put, Yeah, let's just go. Why did I copy the frame? I could just press one key and get that back. That and that. And then that's the last stage, so we could have that up in there as well. This is the current look we're looking at. So, okay. I guess this says this, that is something that we need to use. The presence of that bundle tells that this needs to be there. Okay, but it needs to be the actual typed bundle. Okay. This is a fascinating thing. This is a fascinating thing. But, in theory, we have that, so we have that part working. Then I just need to yoink cross-edge thing. So, okay, so since this is another level, if these both had the A in there, it wouldn't work too well, which is why I will try giving them both A, so that they all have the same compliance value. Even though, again, no, that shouldn't work. And then this one will be the rest position attributes. So here, if we get the rest length and put it over there. Again, if you're learning from this and wanting to test out some things, this probably isn't how you should be doing that. This definitely isn't. But it is interesting. So this should be B. I'm not actually sure if it is, the format is necessary. Deconstructing it into its base values, and then that one is simprop. I'm going to assume B because it's, oh wait, no, that's the wrong one. Simprop, okay, yeah, it just needs to be B. Have a different name, I assume. The compliance will be 0 anyway. So let's just go and copy you into here, put that into there. And then plug it into there. Let's see what happens. Compliance is 0, but nothing has changed. Is that because, yes it is, because I forgot to actually reconnect that. We can see that now something is actually occurring. Still trying to go to its rest position, but because the rest length is completely artificial and made up, completely fake, that happens, leading to a very, very interesting effect. So, if we're hacking this together, we don't label with C. So the format is needed. Format is needed. Very interesting. Very, 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 very interesting. If I were to mute you, I'm assuming it just defaults to 0. Which explains why, when this happened, it collapsed to 0. So if I muted these two, it would just collapse, because while the data was there, the original data, that happened. That's interesting. While the rest length and stuff is there, they could, in theory, be maybe. This is all a big maybe. Keep that in mind, chat. It could be like this. There we go. Oddly enough, this crash has happened before where I hit Control X and for some reason it crashes, but usually that's only when there's node links. Let's see. Crash property operator, yada yada, pass through. Load modules, yada yada. I'm just looking through the crash log. I should learn to read these one day. When I have bucket loads of time on my hands. Exception access violation. Exception module, yep. Stack trace string length. Property string length storage. Oh. It's from the string. The UI. RNA property string get. Okay. Interesting. So there's a loose little thing happening there. Let me... Well... I need to... Yeah, I'll look into that later. Restart! Okay, and we're back. And so much progress is lost. Oh no. Autosave! Autosave, my beloved. Where are you? I'll recover autosave. There we go. Okay, we're back. Whew. That was bad. Okay, so I'm assuming the crash was because I hit Control X, there was nothing for it to go to, and the string was looking for something and then crashed. Something along those lines. Let's go and save this in its current state. Let's just go and press regular X to go and chop all that out. Again, this is a fascinating setup. It is definitely different than previous geometry nodes things, I guess because it's... The XPBD node needs so much more data and in specific formats that I am not used to. Let's keep all that in there. Let's save this. So now, with all this, we have a working thing there, and then if we go and set the thing there, and then set it to 0 again, if I had enough simulation time on my hands. Okay, so at the end of the stream, it took a while, but we got there. We can see, yes, the compliance and stuff does work. It's trying to return. Oh, it's still having, oh right, because I set the compliance to be 0.1. If we do that, then we can see, like that. So, with all that out of the way, let's turn up normal even more. Oh, that's fun. A fun guy. Living its best life over there. It won't tear because we don't have the tear set up, but we could do that. We could just straight up add in tearing right now. If I were to go in and use an edge split node, edges node. Oh, also, in other little, not rumors, but little things I heard through the grapevine, there might be a merge by, did they add that in? No. There may be a merge by distance asset replacing the weld modifier. I'm not entirely sure about that. I just saw that through the grapevine. And I am very glad about that because the name weld, I was like, that one could be merged by distance. But as we can see, we already have a simulation has this. And I can compare the rest length to the current length. And then, if that ratio is incorrect, divide, that should probably be like this. If we have those two, and then use a greater than, or a less than, I forget which, is greater than 0.1, it will... greater than 1.1. Let's go and do that. Yep, still incorrect. Flip it again, we just flip it until it works. We can see some tearing is working. Though it seems like the normal is causing quite the drift. So let me use the position, what we had previously. Average, do a nice subtract, normalize, all that good stuff. Now, I should make this separate per mesh island. Mesh island. Island index, just take the average, normalize, do all of that, scale, plug it into there instead. I do need to put these into node groups, but I just want to try the simulation with no node groups to start out with. Let's see. We just need to increase the pressure, but when we release the pressure, still quite cool. And let's turn off the effectors because they're not needed here. We have that. Oh, and it collapses in on itself. Intriguing. Just intriguing. So we have that, and then the tears occur. Look at that! Oh, that is beautiful! Whoa! Dang. Okay. We are saving that. Look at that. Okay. So once the simulation is up and running, that's good. Does the Harry simulation use CPU or GPU? GPU. CPU. I am so sorry. Everything in geometry nodes uses the CPU, which there's a very good reason for that. Very good reason. Now with this, yeah. I guess the simplest setup for cloth with tearing. In theory. To be honest, like the bundle stuff still confuses me a fair bit, a lot. But that's not too bad in terms of like the size of the node group. Okay. In the its simplest form, it's not that bad. Now these parts are frozen. Like porting the new data through there is still needed. I would need the transfer attributes and all that. Maybe I'll do a stream tomorrow to go over some of that because there is some really funky stuff that can happen. I need to test that, especially with the get attribute names node, which I do like the new name. The name went through so many iterations, but I do like this name. It is the best out of the bunch. The panels are very nice, having that and that. But yeah, also thank you, Jax, for helping out with this node. I'm so glad this made it in. So many things are possible now. Yeah, getting, transfer... These two will be a very amazing combo. And I need to test this with several things that I cannot discuss. Boom, 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 and then that. Amazing, absolutely amazing. Smooth so that we can see that, and it just turns into, it's like a bubble. It's like a bubble except much more violent. The way it just scatters into a million pieces. You love to see it. Alright, and with that, that's it for today, everyone. Lots of amazing stuff. Now, again, in your regular workflows with these dynamics groups, of course, you will never have to look inside the geometry node tab. That's the point, the editor. We'll just need to look with the modifiers, doing all that. That is the point. The point is a pseudo replacement. Again, it is an experimental feature, maybe in 5.2, might not be. We'll see how it goes. And you need to enable it in the experimental preferences, in the preferences experimental tab. So it's a look at the future of Blender, and it is very exciting. Very cool to see. And also this node, keep a lookout for that. You can use it for many, many great things. I forgot to go over like the general workflow with it. It is basically just get list item, get list length, use it with the repeat zone or something like that. Or maybe if you just want the first UV map, or the first implied active UV map, you just go and do this and this with your geometry, 2D regular vector. On the face corner domain, get the first one, and that'll be your first UV map. I know some people will appreciate that, so that you don't need to manually input UV maps for various assets that you may get from various places. That is great, that is amazing. And then if you want to transfer all the attributes, maybe you can do that. I need to figure out how this node works. Okay. Oh wait, is this the first time that panels... Oh. Inputs after panels. Huh. That is, interesting. Interesting. Oh yeah, because it's hard-coded, you can do that. I forgot about that. And then what else? Keep a lookout for the scene time node in the shader editor. That may be coming around if everything else goes well. And then, what else? I feel like I'm missing something big. But I'll probably remember it tomorrow if I'm working on more tests. I do want to try implementing a collider with this because I think that'll be quite simple. Famous last words right there. But given how most of it... it's just the management stage that I'm working on. And then, like, we can still do geometry editing. So in its simplest form, I guess this is how you can make it work. It just needs to know with the typed bundles Oh, it's not even connected. Whoops. If I put that in there. Okay. That's why it exploded in a spectacular fashion. There was no, like, particular thing there. Okay. It does look good. That is quite nice. So, just for... The naming convention needs to be there as well. Though that is right there. Okay. It's complex. But it'll work. It'll work. Complex, but it will work. Those values do not specifically need to be put in there, though maybe for the initial data it does, for it to be initialized. In theory. Yeah, there's much more I need to learn about this, and I am quite excited about it. A new fundamental building block node. You love to see it. Alright, thank you all for watching. If you have any last questions, ask them now. We have, okay, 32 people here. Good. Thank you all for watching, and let's see. I'll just wait for a few seconds for the potential questions to come in. If not, that means I can go and eat lunch faster. If I just turn up the compliance, we get that. Cool. Just a complete spaghettification of a water balloon or something like that. Okay. Yep. Oh, I forgot to check point clouds. Do those actually work? Excited for lists in 5.2 because of all the rigging potential. Yes. Maybe I'll look into a Armature bone names node. Get bone names node. Yeah, that might work. A get bone names node, because I already have a blueprint, or previously I think I might have made, I'm not sure if I actually got it working or not, a armature to points node. That should be get attribute domains node. That's actually an interesting topic. Let me just yap about that for a second. During the dev discussions about this node, there was some hesitation about whether this was the right way to do, like, getting attributes. And I think the consensus was this isn't the ideal method because it's not getting the attribute, it's getting the attribute names. There was a prototype that I made that got the actual attribute, like the named attribute node. I guess that shows why this method works fairly well. All right. Again, the way this is supposed to work is like this. So if you want the UV map, you just do dun dun dun, and it goes. But this doesn't get the attribute. The attribute would get, like, you know, the actual the data, the type, and the domain. I tried outputting those as integers and everything. Yeah, if there was an issue with that, because, oh, you're right, there was a nasty issue with that, which is why I guess we landed on this. But with this method, it assumes you know the types and the domains beforehand, which is intentional. If you want to go and manipulate every UV map, you want to go and just get the UV map. So the filtering is done beforehand, before you get all the attribute names. So you only need those. Now, it does mean if you want to get every type in a row, or specific types in a row, if you still want the filter and all that, because we have the named attribute, which doesn't have a menu socket or anything like that, you would need to have... Oh, could this possibly have a menu socket? So that you could string together... Because this is the first time... No, I would need a different menu because... that... But syncing up these two isn't really possible yet, which leads to, you know, other things like the named attribute node. You wouldn't be able to sync up these ones as well. So, with the way Blender currently works, this setup is needed. Was wondering the same thing about menu sockets. Yeah, it's just the way Blender works at this time. Since I don't know if it is possible for these nodes to get menu sockets. If it is, maybe I'll look into that, but I kind of doubt it. Due to my inexperience, I don't know the technical reason, but I assume there's a technical reason why some of these are not menus. Probably, I just don't know. But because of that pseudo limitation, this method is actually good because we just work on the different domains in their own unique way. If you have a matrix, you can't, you know, use it the same way as a UV map, so you will need different handling for all these different types. So it is necessary. But it is good. It is good. It is quite good. Anything that's everything. Alright, 34 people here. Wow, I am still amazed by that. Thank you all for watching. I hope you all enjoyed. If I can figure all this out, I may put something up on Gumroad, or let's just get a nice view of the simplified, in quotes, barely functional cloth simulation setup. But this was actually very good. I'm very glad I did this, because I got to actually look at the PR comment for that, the commit message, which helped out a lot with all of that. Ooh, that one's spinning. That. But yes. Thank you all for watching. Almost 3 hours. Oof. Too long. Thank you all for watching, and I will see you next time. Have a good one.